today we're talking about logarithmic functions. Logarithmic functions are the inverse of exponential functions. If you think about all the work we've done in the past, everything we do has an inverse. Multiplication, 2 times 4 is 8. Well, the inverse, that's division. 8 divided by 4 gets you back to where we started from, 2. We've done powers. 2 squared is 4. Well, the square root of 4 is 2. Back to where you started from. Same thing with exponentials and logarithmics. They are inverses of each other. If I have the graph of 2 to the x, it looks something like this. Well, the inverse of that would be log base 2, matching that base and this base, looking something like this. We also have the idea of e and natural log. Okay, e is the base of this one, so e to the x is this graph right here. The inverse of that would be natural log of x. So graphically, this is what we know about logarithmic functions. First off, they're going to go through these 3 points down here. I'll talk about those in 1 second. So you can see these 3 points right here. Do that in 1 second. There's 3 possibilities. You could have log base 2 of x. Okay, that's a number bigger than 1, which means that graph is going to look like this. It's going to go to the point 1, 0. It's also going to go to the point 1 over that base, so 1/2, -1, and then to the point whatever the base is, comma 1, so 2, comma 1. And it's going to look like this. The second possibility is let's do log base 1/2 of x. Now this is a number between 0 and 1. It's a fraction between 0 and 1. And that's going to flip the graph over. So it looks like this. It's a polygon graph. It's basically the same graph flipped over. Okay. It's also at the point 1, 0. It's going to go to the point 1 over a, so that's 1 over 1/2, so that's 2, -1, and to the point a1, so that is 1/2, 1 right there. Okay. These all have, okay, so it's going to talk about this right here, a less than 0. So let's say log base -2 of x. This does not exist. You cannot have a log to a negative base. So this graph would not exist. Okay? So domain and range. There is a vertical asymptote at x equals 0 for all logarithmic functions, which means we never cross that y-axis. So our domain is going to be x greater than 0. We're going to start at 0 and go to the right forever. And our range will always be all real numbers on these guys. And again, the points of interest are always these 3 points, so make sure you get those down. So if we're wanting to solve problems that involve logarithmics, for instance, log base 3 of x equals to 2. Log base 3 of x equals to 2. I wonder what x is. Well, chances are pretty good that none of you can do the logarithms in your head. That's not something we typically develop a skill for. So we need to know how to solve it. I said that logs and exponents are inverse operations. So just like we had 2 times 4 equals to 8, to undo that we divide it by 4. Get back to 2. Here, we have log base 3 of x. We have to undo that by taking the exponent of both sides. The base is 3, so 3 to the power of log base 3 is going to cancel. We need x equals to 3 squared, which is 9. So that's one example of solving. What if I gave you log base 2 of 8, for instance? some sort of exponential form. Notice, log base 2, or base is 2. Can 8 be rewritten as an exponent involving 2? Isn't 8 nothing but 2 cubed? So if I can rewrite this as log base 2 cubed. Logs and exponents